You mentioned it earlier. It's like this continuous verification where you start with your expectation and you would like to see that the system still works under many different conditions. Can you maybe provide some examples or practical examples from what verification-driven development can look like?
Sure. So usually continuous verification refers to, it's analogous to CI and CD.
Yeah.
So CI gave us all these advantages because, the theory is bugs get limited the faster you can jam everybody's code together, right? Because the code is like the common understanding of stuff. So anybody writing in isolation is going to get less aligned. So CI just jams it together. Great. CD gets it in front of customers faster, right? Or end users. So again, it's shortening feedback loops. And CV is, okay, now that it's running, how do we shorten the feedback loop on systemic behaviors? And that could look like a lot of things. But for infrastructure, for example, imagine you have, I don't know, pick a piece of infrastructure.
RDS from AWS.
Okay, so what kinds of properties would you expect from that service?
Good process on write and reading.
Okay. And typically, what would you be putting in and fetching out?
Let's keep it simple. SQL.
Okay, great. So your bunch of SQL queries, and there's some relational thing there that you want to put in and put out. And imagine you have the best observability in the world hooked up to this, so most of the time that it's performing great. So even with the best observability in the world, it's still kind of a binary signal. Like, yes, it's working until it isn't, and then you're back in reactive land. Yeah. So to be proactive about it, what can we do? We can flood it with certain kinds of traffic, like many simultaneous connections. Since it's SQL, payload size going in probably isn't much of an issue, but coming out is. So you can vary the response data sets that you get back out. You could have some SQL queries that are going to take longer than others. And then number of requests per second, right? So say we've just got those 4 variables. So what you want to figure out is, where does this thing tip over? Like, where does it stop working the way your end users want it to work?
And it shouldn't be like now, yes or no. It needs to be like a phase where you can see, okay, it's shifting in the bad direction and not like good or bad.
Yeah. So we want to know what that boundary is before the end users hit it. So there's 2 ways that we can stress the system. One is with live traffic, and we can kind of like funnel it into hot points. The other is synthetic load. Doesn't really matter to me which of those you pick. Obviously, the live traffic is a little bit more authentic if you can do traffic shaping to do that. But imagine you've got certain treatments now where you say, okay, I'm going to vary these 4 variables. And what I'm going to look for is, since it's an AWS service, rate limiting or errors or timeouts. And ideally, you're looking to find a statistically significant increase in one of those things before applications start failing. So, presumably your application has some sort of retry logic. If something times out, or it'll just try again. Great. So you establish, here's my baseline rate of timeouts, latency, rate limiting, load shed. Yeah. And now I'm going to gradually increase the payload side coming back, right? That's one of the variables. And at some point, one of those observations is going to statistically increase, and you go, okay, now I'm approaching the limits of what this infrastructure can handle. So then you can taper that back down, then increase the number of concurrent connections, find the same point, note that, decrease that, now increase the requests per second, find the same point. And now you can kind of like triangulate or draw a line around those points and say, okay, this is the map of where this piece of infrastructure fails. As long as I'm inside there, in terms of requests per second, SQL sophistication, payload size coming back, as long as I'm within those boundaries, I'm generally safe. I've empirically proved that. And once I approach one of those limits, I'm going to be in trouble. Okay, this is a level of detail and understanding, operational understanding, that almost nobody in the industry has about their infrastructure. So continuous verification establishes those boundaries And then you can do all sorts of interesting things like that. You can set SLOs around those. You can set alerts around those so that you know if you approach them, you're headed in troubled water. That's proactive. And then the continuous part, you do this every day and track it over time, and you'll be able to detect changes in your infrastructure or in your complex system interactions through simple change point detections, that when something else happens, AWS brings up another AZ, or you get a bunch of noisy neighbors on the underlying fabric at Amazon or whatever, you'll be able to notice that or be alerted to that. And again, that's just a signal, hey, operator, something's different in your infrastructure. You should probably pay attention to this. That's a level of insight that almost nobody right now gets into their infrastructure.